So for this lesson, we're going to look at expressing concentration in a variety of different ways. The first one we have is our weight volume percent, which is basically defined as the mass of the solute divided by the volume of the solution. So the mass of the solute would be in grams, the volume of solution would be in mils. This relies on the fact that solutions are about 1 gram per mil in density. If you wanted to have the mass in kilograms, you would have the volume in litres, again because 1 kilogram is about 1 litre as far as solutions go. So in that sense, you can sort of look at this as really a weight percent, but just talking about volume. And let's have a look at a quick example. So if we have 3.2 grams of sodium chloride going to be dissolved in water and made up to 1 litre, what is the weight volume percent? Okay, so here's the solution. Our weight volume percent would be that 3.2 grams divided by our 1000 mils. Again, we've got to have, if we're using grams here, we would have to have mils here, then multiplied by our 100%, and this would give us 0.32%. So a volume percent is the next thing we're going to look at, and basically it's similar. It's just that instead of having a look at a solid dissolved in water or some other solvent, we would have a look at a different solute, in this case a liquid, dissolved in some other solvent. And so here we're comparing the ratio of volumes, and of course we've got to have the units either both in mils, or this could be both litres, but either way they've got to be the same units, and then multiply by 100%. And so for an example, consider that we'd have 100 mils of ethanol dissolved in water and made up to 1.12 litres. What is the volume percent? And so the answer for that would be the 100 mils divided by 1.12 by 10 to the 3 mils times 100%, and that would give us an answer of 8.93%. Next up we have our parts per million. And so parts per million is a way we express very, very small concentrations. Again, we want the same unit. So if the mass of our solute, and by the way, solute means the thing that's going to be dissolved. The solvent is the thing that's doing the dissolving. And when solute and solvent are together, the total is called a solution. And so if we're going to look at part per million, we have the mass of the solute, which is in grams. We have the mass of the solution, which also must be in grams. And because we deal with such small numbers, we multiply it by a million, and that's how we get parts per million. Let's have a look at a quick example. If we have 1.4 by 10 to the minus 5 grams of carbon found in a 1 gram sample of air, so if we somehow captured 1 gram of air and measured the amount of carbon that was in there and found it to be 1.4 by 10 to the minus 5 grams, what is the concentration in parts per million of carbon? And so the answer is 1.4 by 10 to the minus 5 grams divided by a 1 gram and then multiplied by a million, and that would give us 14 parts per million. So hopefully a lot of these concentrations make sense. And the main thing is to remember that you must use equivalent units. If you're doing the volume percent, then just make sure they're both in mils or both in litres or something. If you're doing the part per million, make sure that both quantities in grams you're looking at. If you're doing the mass volume percent, this is where you're comparing a mass to a volume, you must have the volume in units that are relatable in the sense of density. So the density of water is 1 gram per mil, and so if you measure the mass of the solute in grams, you must have the volume of the solution in mils. Unlikely, but if you were going to measure the solute in kilograms, it would be appropriate that you measured the volume in litres, because 1 kilogram of water weighs 1 litre. So hopefully that's clear. Thank you.